Hello everyone, this is 315 315 MVA power transformer. It's stepped down from 400 to 220 kV. So these are the lightning arrestor. Also install this 3 numbers because one for each phase, and that is the main tank. In fact, it's quite big because of the size and rating of the transformer. 315 means it's huge, because normally in power stations like in 132 by 33 kV substations, you will have ratings of 5 MVA or 10 MVA, but in this substations we are having this 315 MVA transformer. So here is the main tank, and there is the cooler control cubicle. This one is the cooler control cubicle, where all the relays, actually whatever relays connection, the winding, the terminals of the relays are all terminated in this panel, and then from here it is taken to the relay panel. So that is the conservator there up, that is the conservator tank, and this is the radiator. And for cooling system, we are installing these fans, cooling fans, and we have pumps also, because the cooling system has 3 types. Here we have the on and on off and all those things, but our purpose here is to actually see where is the location of the Buchcholz relay. You see, there is the Buchcholz relay there. See, there is the Buchcholz relay. This is one of the main relay in giving protection to the transformer. In addition to the pressure relief device, the oil surge relay and all those things, WTI, OTI, we have this Buchholz relay. It is actually a gas operated or a gas actuated relay, based on the formation of the gas. If there is no gas formation in case of a fault, that means the installation of that is of no use, because in case of a fault inside this main conservator tank, because of any winding to winding short circuit, or because of earth fall inside this, then heat will be developed, and because of the heat, the oil inside will be decomposed into its constituents, like gases like hydrogen, carbon monoxide, ethylene, methane will be generated, and the gas generated inside this, it will rise up, because gas is lighter than oil, so it will rise up and try to rise as much as it can and try to reach the conservator tank, and it will rise through that pipe. Actually, there is a pipe connecting the main tank and the conservator tank, and we have installed this Buchholz relay in between the main tank and the conservator tank. So these gases which are generated, they will be trapped inside this relay, and the construction of the relay is such that if there is a gas formation, it will be trapped there, and two sets of NOs contacts have been provided. Just a little bit up of the relay is your alarm contact, and a little bit down is your trip contacts. That means if the fault is severe, the trip contact will get activated. That means it will get shorted. So the rises of the gas will replace the oil there, and the float device which have been installed inside this Buchholz relay will push the oil down, and because of that, the contacts will be shorted. I think it's a magnetic contact installed in there, because normally we don't use mercury contacts in big transformers, because in mercury contact mean, like if there is an earthquake, then you may get false tripping that will affect the power flow because it's the rating of this is huge, so that's why it will affect the power flow in any region. So that's why we are using this magnetic contact. So that is the purpose of this Buchholz relay, where it is installed. You can see that is the conservator tank and the main tank. So the installation of this, it's easy. When you look inside the relay also, you will have only 2 sets of contact. The moment it is empty because of the occupation of gases inside replacing the oil, both the contacts NOs of one for alarm and one for tripping will get activated.